In this problem, the first thing we need to do is to produce our diagram. In our diagram, we have an aerial, and we're told that the aerial, the antenna, is 7.5 metres tall. We're told that there's a wire connecting the top of the aerial to the ground to support it, and the wire connects at a distance which is 5 metres from the base of the aerial. We need to find the length of the wire and the angle that that aerial makes with the ground. First things first, let's name the sides on our triangle. X, the one we're trying to find out, is the long side, so that is the hypotenuse. The angle opposite, the side opposite the angle is the aerial, and the side adjacent to the angle is the ground, which is the adjacent. Next, we write down our trig acronym, SOHCAHTOA. SOHCAHTOA. And let's begin to work. First thing with this problem is to find the angle itself. And to find the angle, we have two sides to work with. We have the adjacent and the opposite. Opposite and adjacent makes it a tangent problem. Let's write down our tan ratio. Tan of theta equals opposite over adjacent. Filling in the details that we know, tan theta equals 7.5 over 5. So therefore tan theta equals 1.5. Or if we prefer rewriting that, theta equals inverse tan of 1.5. This gives us an angle of 56.3 degrees, or converting that to degrees, minutes and seconds, 56 degrees and 18 minutes. The next thing is to work out the length of the hypotenuse. We can do that in a couple of ways. We can do it using trig, or we can simply do it using Pythagoras. Pythagoras is probably a little bit easier, so we'll do that. I'll clean this work off the board, and we'll begin to use Pythagoras. Pythagoras tells us that the opposite squared plus the adjacent squared equals the hypotenuse squared in this case. Let's work through that. That means 7.5 squared plus 5 squared equals the length of the wire squared, or 56.25 plus 25 equals h squared, or therefore h equals the square root of 81.25, which equals 9.01 metres. And that's the length of our wire, h or x.